Hey, geometry. We are headed into the second section or second half of section 8.6, law of sines. I said that in this video we're going to do this part that we skipped over. We did do the story problem before, but we're going to skip over and we're just going to do parts A, B, and C. This part of the law of sines we get into a lot deeper when we get into trigonometry, which some of you guys will take next year. But I kind of want to introduce it to you. We talked before, like, I don't know, maybe a couple weeks ago, about how if you have like three sides of a triangle, like let's say you have 14, 6, and 3. Okay, let's say that those are three sides of a triangle. Okay, I'm going to make my bottom side of my triangle be that 14 side. Okay, have him be the bottom side, and then if I have the lengths that are 6 and the lengths that are 3, 6 plus 3 is 9, which is not long enough to make that bottom side. So basically those two sides are not going to come together to make a triangle. And that's kind of what we're seeing here. We have ways to test law of sines to see, okay, is it going to make a triangle? Like over here, when we have this scenario happen, you know, we're going to have one side that's going to be shorter, and the sides of the triangle are not going to fit together. So basically they're saying I can't just slap three numbers together and assume that they make a triangle. If two of the sides don't add together to make up bigger than the third side, then you're going to have this big open gap here in the middle. Okay. So this is kind of a flow chart that you're going to use to do these examples or parts A, B, and C to determine, do I even have a triangle? Am I going to end up with two triangles? Okay, so I'm going to go through this right side first because it's a little less complicated. Okay, so you have two sides when you're doing this flow chart. You have where your angle that you're given is less than 90 degrees, and we'll go through that here in a second, or you have your angle is greater than 90 degrees. Okay, so if your angle is greater than 90 degrees, you're just going to look at these two scenarios. Okay. If your angle right here is greater than 90 degrees, as these two both are, okay, if the side that is opposite that angle, if you're calling your angle A, your side is going to be side A. Let me zoom in on this. Your side will be side A. And if side A is smaller than side B, basically he's not going to be long enough to touch down on this opposite side. So you're going to end up with no solutions because that triangle won't come together. But if A is greater than B, that side opposite your angle is bigger than B over here, then he will touch down and you will end up with one solution, and that's everything's good to go. Okay, so when A is greater than 90 degrees, you're going to follow these two steps and just kind of check the relationship of A and B together. And that's going to tell you what to do. Okay, now a little bit more confusing if A is less than 90 degrees. Okay, we have to look at kind of one of these scenarios. Okay, so they say A equals H over here, or A is less than H, or A is greater than H. But H from the front side we determined was B times sine of A. That was in the area formula. So I went ahead and replaced that H with B sine of A. So what we're going to do is if A is less than 90 degrees, we're going to check the relationship of A and B times sine of A. Okay, and that's just what we're going to do. So if there is one solution, A will be equal to B times sine of A. Which will really mean that we have a right triangle going on here, and there's only one solution. There's a right triangle. He's perfect. He's good to go, and then we can use the law of sines to find any of the other missing pieces. Okay. Here, if A is less than B sine of A, we kind of have the same scenario as we did over here. This little A is not going to be long enough to touch down on that third side, and we're going to end up with no solutions. We basically have a triangle with a gap. Okay. And then this scenario, you could have the scenario where there are two solutions, okay? And one of those solutions, and those solutions, we'll get two solutions when A is greater than B times sine of A, okay, when that scenario happens. And basically what's happening there is I could end up with the solution where I have this being my triangle, okay? And notice that this is angle A and this is side A right here. Okay, but then what I could do instead is I could swing that side A over here. It would be just as long if I swung him over on this side, but I would end up with this triangle here instead. Okay, so I could end up with two solutions. I could end up with a solution where, you know, I have like a really skinny triangle here, or if I swing that side over here, he would look a little bit longer, right? That's what he would look like if I took this side and I swung him over, making him a different sort of triangle where these both sides A are going to be the same length, okay? And so we'll look at those. You also end up with one solution when A is greater than B, okay? So we'll go through here and we'll kind of see what we're given, and we'll see how many solutions we will have. So no solution, one solution, two solutions. Let's see what we have going on here. So I went ahead and wrote out RST and lowercase rst. They give me this. We can see from the triangle kind of what this thing's going to look like. And so basically, if I were to set up my law of sines, I would have an R match up with an R, and this would match up with S, which we don't know, okay? So that's one thing that we maybe need to solve for. But let's see how many solutions this will have. Will it be a scenario where we don't have any solutions, where the other side is not long enough, okay? So what we're doing is we're looking at the angle being 105, okay? So this one's kind of nice because this follows the right side, okay? A is greater than 90 degrees, so we're going to follow this side here. And all we need to determine is, so in this scenario, R is kind of like my A. They just named it R instead. This is lowercase a. And then if you want to call this lowercase b, and this would be capital B, and this is capital C, and this is lowercase c. They've just named them something different, which is okay. Okay, so we have our capital A is 105, which means it's greater than 90, so we're following this side. And then we just need to determine, is A less than or equal to B, where we would have no solutions, or is A greater than B, where we would have one solution. Okay, A is 9, B will be 6, so A is greater than B, we will have one solution. And so then we just need to fill in the rest of this triangle. So I'm going to put one solution over here. Okay, and then we just need to fill in the rest of this stuff, okay? So we need to find out what S is. Let's do that first, okay? So what I can do is I can set up my law of sines, okay? The formula for that, if you need it written over here, is sine A over A equals sine B over B. And it really doesn't matter what these variables are called. Basically, you're just putting the pieces that go together here, the pieces that go together here. So maybe this is B and C or something else, right? Okay, so when I fill this in, I'm going to do sine of 105, okay? And he goes with 9, so I'm going to put 9 in the bottom. And then this one's going to be kind of weird. I'm going to do sine of S, because we don't know what S is, over 6. Okay, so this is going to look a little bit different. All right, now I'm going to cross multiply. So I have 6 times sine of 105 equals 9 times sine of S. That's what he will be on this side. Okay, and then if I want to get S by itself, or sine of S by itself, I would have to divide by 9. Okay. All right, and let's go ahead and figure out what 6 sine 105 divided by 9 is. So 6 sine 105 divided by 9 is 0.644. Okay, now that's kind of a weird, like, is that an angle or is that a side? Well, here's the deal. That is equal to sine of S. Sine of S, okay? And we did this before in the right triangle trig in like section 8.4, I think, where if you're trying to get S by itself and you have a sine in the front, you have to do what's called inverse sine, okay? So the inverse sine is going to cross that off. So S is going to be equal to inverse sine of this 0.64. Okay, so I'm going to go inverse sine. That's that sine to the negative 1 power. And I'm going to use the answer. I can plug that into my calculator so I don't have to retype. And it's 40.1. Okay, so my angle S is going to be 40.1 degrees. Okay, I'll put that over there. All right, and then I can figure out what T is and what angle T is and what side T is. So how do you find out what angle T is? 105 plus 40.1 is 145.1, so 180 minus 145.1 is going to give me 34.9 degrees. And then I can just use this, the law of sines like I did here to find T, okay? So let's see, can I do that over here? Yeah, let's do it over here. Sure. Okay. So something over something equals something over something. All right. I'm going to use my same pair that I had before. The A's, which are really actually R's. So I have sine of 105 over 9 is going to be sine of 34.9 over t is what I'm going to solve for. Okay, and now I just do like normal. Okay, sine of 105 times t and 9 times sine of 34.9. So let's do 9 sine 34.9 equals t times sine 105. And then to get the t by itself, I need to get rid of the sine of 105. Okay, and I can type this all in. So 9 times sine of 34.9, 9 sine 34.9 divided by sine of 105. And we have 5.3 is what that third side will be. Okay, kind of check to see if this seems reasonable at all, because like 9 and 6, if those are my other two sides, this probably isn't going to be like 105 or something like that, right? 5.3 seems pretty appropriate. Also, when you're looking at this, your angle should, your angle that's largest should be opposite the side that is largest. So 105 is largest, 9 is the largest side. 40.1 is the middle angle, like the angle that's not the biggest and not the smallest, so it should be opposite the medium-sized side, and then your smallest angle should be opposite the smallest side. So kind of check that to make sure that that is the case, okay? All right, so in B and C, we're going to go through and we're going to do the one solution, no solution, two solutions, but I'm not going to solve these guys because we did that in part A, and I don't want to make this video too terribly long. So in B, they give us that A is 54 degrees, and they give us the angle or the side opposite is 6. And then B is this side that's connected to A here, okay? So we want to look at this, and if we use our flow chart, A is 54 degrees, okay? So we're not looking at the easy side, we're actually kind of looking at the hard side, okay? A is 54 degrees, which means we're less than 90. So then we need to look at B times sine of A, okay? B times sine of A. So we're comparing A and B times sine of A. So if we plug those numbers in, A and B times sine of A, okay? A was 6, B was 8, sine of 54. I'm just plugging those numbers in for B sine of A. And if we do 8 times sine of 54, okay, we find that this guy is 6.47 and this guy is 6. So what I have in relationship to each other is that A is actually less than, B times sine of A. A is less than B sine of A because 6 is less than 6.47. So I go back up to my flow chart, and A is less than B sine of A, which means I will have no solutions. Okay, kind of like the drawing suggests, this side right here is not going to be long enough to touch down on this side, so there is no solutions. So I couldn't even solve this thing if I wanted to, right? Okay, and in C, okay, I have A is 35 degrees, lowercase a, or the side opposite, is 17, and then B is going to be 20, okay? So I'm looking at the hard side again because A is 35 degrees, so we're looking at this scenario happening over here rather than this one. And what I want to do is I want to compare A and B times sine of A, okay? So lowercase a is 17, B is 20, sine of 35, okay? So let's calculate 20 times sine of 35, and that is 11.47, and 17 is greater than 11.47. So we have A is greater than B times sine of A. So if we go back up to our chart here, this one says A is less than B sine of A. Nope. A equals B sine of A. Nope. A is greater than B sine of A. Yep, that's what I have. So I will have two solutions here. So two solutions. And that's what I'm looking for. I'm not going to make us solve out both of those solutions because that would be kind of messy, but this is what it would look like. So basically I have this 17 side here, 20 is here, 35 is here, but this 17 side I could also swing over here to make this triangle look really skinny like that, okay? I could swing him over so that he is making this side like that, and I would end up with these two very different looking triangles, okay, with dimensions that are both the same, okay? So there's kind of how that works and what happens to that, right? So that is all for section 8.6. Next video we'll dive into 8.7, and I think that's going to get us about to the end of the chapter, okay?